In this video, we're going to discuss graphing sine and cosine functions. We've been discussing that sine and cosine are functions of the angles inside them. And now we're going to graph it as a function of t, the angle. So the first thing is to put in at least the familiar angles like pi 6, pi 4, pi 3, anything that you would that would come from and unit circle over here, and so on and so forth on the t line, and then find the y value for those and graph them. So the plan is to graph y equal to sine of t, the simplest form of sine and cosine. I guess the simplest form of sine. So to find, as you would do with any other function, you plot as many as you can and for the starter. So what I did over here is I went to the unit circle, started from 0, put in 0, pi 4, pi 6, pi 4, pi 3, pi half. Then I went to the second quadrant, 2 pi 3, 3 pi 4, 5 pi 6, and pi. Third quadrant, 7 pi 6, 5 pi 4, 4 pi 3, 3 pi half. And the fourth quadrant, all these values. And then what I want to do, this is again by plotting. So I want to plug in every value in the sine function. I've already done that. This is just using the first column of the table that we use. It's 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Then I do the second quadrant. Second quadrant here, sine still is positive, so I use the values that I have. The denominator here is 3, so I have to use that one, square root of 3 over 2. Denominator here is 4, square root of 2 over 2. Denominator is 6, 1/2. And then this one is the end point is going to be 0. This one, this table is the one in the third quadrant. And in the third quadrant, everything has to be both sine and cosine are negative. Right now, I'm just discussing sine. Sine is negative, y value is negative. Therefore, whatever I find from the tables before, from the reference table, I put a negative sign in front of it. Denominator 6 gives me negative 1/2. Denominator 4 gives me negative square root of 2 over 2. Denominator 3 gives me negative square root of 3 over 2. And then the last one is going to be negative 1. Over here, this part is all in quadrant 4, and in quadrant 4 again, y is negative, so all the values are going to be negative. And on start, denominator 3 in the reference is negative square root of 3 over 2. Denominator 4 is negative square root of 2 over 2. Denominator 6 is 1/2. Negative 1/2, and 2 pi becomes 0. And I know that if I go round and round the unit circle, I repeat the same process. That's why the sine function is periodic. So let's plot all these points first. And so for 0, I get 0.0. For pi 6, I get about square root of 2 is about 1.4, divided by 2 is 0.7. For pi 6, I'm sorry, I'm getting 1/2 right here. For pi 4, I'm getting square root of 2 over 2, which is about 1/7, is 1.4, I'm sorry, divided by 2. And then for pi 3rd, I get a little higher than that because it's it's going to be the square root of 3 divided by 2, which is 1.7 divided by 2, so a little higher than that. And then pi half is going to be 1. This is supposed to be a little higher than that. And 1. And then for 2 pi third, again, I get the square root of, and for 3 pi fourths, I get square root of 2 over 2. For pi 5/4, and again, I get 1/2. For pi, I get 0. Then over here, I get the negative value. For over 6, I get negative 1/2. Then pi fourth is a little higher. Pi third is a little higher than that. Then 3 pi fourth is 1. And then symmetrically goes down and 0. So if I connect it, it looks like this wavy. You can use other points in there also, but it looks like that. And then I know that everything is going to repeat, so I know that this is whatever I have between 0 and 2 pi would happen again between 2 pi and 4 pi. And over here, I know that this is going to happen again. Whatever I have, it goes on the other side as well. So that's the simplest form that we can have. It's y equal to sine of t. In here, interesting things to know. It seems like if I average out all the values above and below for this curve, it ends up at y equal to 0. And that's called midline. This one has midline as y equal to 0. It's actually y equal to the average of all the values of the curve. And we're using the term average loosely at this point. And then what is the amplitude? Amplitude is the highest distance you can get for the curve from the midline, and that would be at point, let's say pi half, or it would be at point negative pi half. This is the highest distance that you can get, which in this case is 1. So amplitude in this case is 1. What is the period for sine t and cosine t? The period is 2 pi. So the next part, we're going to come back and we try to do the same thing for cosine of t, and then we would discuss the all the transformations that we can do in either of the functions. So I'm going to erase the board and continue. Now let's put the points plot using these points. At 0, I get 1 right there. At pi sixth, I get square root of 3 over 2, which is about here. Then at pi fourth, I get square root of 2 over 2. At pi third, I get 1/2. At pi half, I get 0. At 2 pi third, I get negative 1/2. At 3 pi fourth, I get negative square root of 2 over 2. And at 5 pi 6, I get negative square root of 3 over 2. At pi half, at pi, and this one is pi, not pi half. At pi, we get negative 1. At 7 pi sixth, we get square root of 3 over 2, square root of 2 over 2 for 5 pi fourth, negative 1/2. These are negative, and 0, and then we are down to our last column, 1/2 and square root of 2/2, square root of 3/2, square root of, and 1 is the last one. So it goes something like that. And that's one period between 0 and 2 pi, because we know that if we go around and around of this one, it just repeats it. So it starts from 1 rather than starting from 0 with sine of t, and it goes on. And I know that it's going to repeat the same stories between 2 pi and 4 pi. So it's going to be a wave that just goes on and on and on forever. So the other thing is, this is also like sine of t. I see that the midline is y equal to 0. And I can feel that I have not done justice to this part. It's not very symmetric. It should be symmetric when the period, the first period is done. The rest of it is going to be symmetric also. And that one is a little higher. Again, hand drawing is not as perfect as you think. And then midline is again y equal to 0. Amplitude again from y equal to 0 to the highest point, there's just 1. Period again is 2 pi. So next, we would like to discuss transformation on sine of t and cosine of t and how everything changes. So we're continuing with graphing graph of sine and cosine functions. Let's see, a general graph of a sine can be transformed up and down, side to side, can be squeezed vertically or horizontally, and we get any type of a just plain sine. Now, if I have a graph of if I want to graph a function of a sine of bt minus c plus d, it's nice to notice that the midline is just the vertical shift, y equal to d, is y equal to the vertical shift, which is y equal to d. The amplitude is what multiplies just the sine part. And then the period is the 2 pi divided by what multiplies t. And the phase shift is c divided by b. How do we graph such a function? So let's see. I start again with a t-axis and a y-axis. I know that that the midline has moved to y equal to 7, so I'm expecting around y equal to 7. Let's say 1, 2, 3, 4, 5, 6, 7 up there to have a midline. Then amplitude, so midline, y equal to 7 midline. Amplitude is equal to 5. What else do I know? I know that the period is going to be 2 pi divided by 2, that is equal to pi. So basically, after, let's assume this is, let's assume this is pi, and this is 2 pi. And then the last thing is the phase shift. What does the phase shift mean? Phase shift is how how much shift we get on the x-axis or the horizontal shift. Let's calculate the phase shift. Okay, phase shift is pi over 6. So about this much. And here is 7 pi sixths. Okay, so from pi sixth plus the period 7 pi sixths, I should have one complete ripple of the sinusoidal wave. And so that's what I'm expecting to happen. If you remember, this was the plane sine function. This was pi, this was 2 pi, and it looked like that. So I'm trying to repeat that over here. At pi sixth, I will be at midline, which is y equal to 0. And then right in the middle between pi, after traveling 1/4 of the 1/4 of the period, I will be at the peak. Basically, peak is 1/4 of the period, and that would happen somewhere around, if I take the period divided by 4, which is pi fourth, add pi 6 plus pi fourth and figure it out, or I can just add and figure out where this 0 is happening again, which is happening right in the middle of these two, and then divide that by 2, and around here there should be a peak. So over here, midline is corresponding to that 0 moved 7 up. This 0 moved 7 up. This peak is in the middle, should move up 5 from that 7 because amplitude is 5. So going up, 1, 2, 3, 4, 5. And I have it right here. And again, the same story at 7 pi sixths, there should be, corresponds to this 0. 0 has moved up 7, so it's going to be right there. And then somewhere in the middle, there should be a lowest part. And lowest part is 5 down, which from 7 down makes it 2 down here. And then this repeats itself, and that repeats itself, and it goes on and on and on. So that's an example when you know the function and you try to graph it. Now let's try to give the next example. We're going to try to give the values for midline and amplitude and period and etc. and try to put actually a function that would follow those values. So continuing with the graph of sine and cosine functions, we often try to use sinusoidal functions to model something in real life. What is given in the problem usually is the average values. There's an amplitude, the period usually is given, and then they tell you what is the value when you begin. For usually at time t equal to 0, the value y equal to something. And so this is an overall feeling of how we have to model it's not a word, this does not appear like a word problem, but this is how you're supposed to simplify a word problem, extract the information that you need. Like I did, you need to figure out what's the average value, what the amplitude would be, period, and a point on that to know the shift, basically the phase shift. And so from then, let's try to figure the A, B, C, D in this formula out. So I'm going to write down y is equal to A sine BT minus C plus D. If I figure out the average, I know D would be the average. The shift up and down is the average. That would be 12. If I know, in the next thing is that if I know the amplitude, I can replace A by the amplitude. The next thing I need to do is to find a period. How do I find a period? Period should be equal to the formula, 2 pi divided by B. So solving for B, pi simplifies from both sides. B is going to be equal to 14. So this is 14. And the last step is, this time I'm not going to use the phase shift. I'm just going to plug in the t equal to 0 and see what happens. Let's rewrite this. Y equal to 3 sine of 14t minus c. C is the one that I haven't figured out, plus 12. Now, if I plug in t equal to 0 in here, y is supposed to be 10.5. So let's do that. This is supposed to be 10.5. And this one is supposed to be, oh no, that one is okay. This is supposed to be 0. So what is coming down to is this equation. 10.5 is equal to 3 sine of negative c plus 12. Subtract 12 from it. So one thing that we want to learn when we're solving for trigonometric equations, we want to isolate the trigonomic equation, the trigonomic function, and that would be what we do here. So I'm subtracting 12 to get negative 1.5 is equal to 3 sine of negative c, divide negative 1/2 divided by 3 is equal to sine of negative c, negative 1.5 divided by 3 is equal to negative 1/2. Sine of negative c is negative sine of c. So sine of c equal to 1/2. This would give me what value, if I go back to the reference table, what value of c would give 1/2? Sine of c equal to 1/2. One of them is pi sixth. The next one would be 5 pi sixth, and so on and so forth. The only difference is, here's pi sixth. The next one is 5 pi sixth. So there should be one extra piece of information to tell me whether the function is rising at t equal to 0 or falling at t equal to 0. Basically increasing at t equal to 0 or decreasing at t equal to 0. And then I decide whether to choose c equal to pi 6 or c equal to 5 pi 6. So the solution to this could be two answers. Y equal to 3 sine of 14t minus pi 6 plus 12, or it could be 3 sine of 14t minus 5 pi 6 plus 12. If the value of y is rising at t equal to 0, the first one, value of y is rising at t equal to 0, then this one's correct. If value of y is decreasing, that was increasing, this one is decreasing at t equal to 0, this would be the answer. So this is an overall way of summarize your word problem into this sort of information. If you need to model the word problem with a sinusoidal function, you need an average, you need an amplitude, you need a period, and you need a value. This could be the t equal to 0 could change to another t, but you need a value of y at some point. You also need to know if y is increasing or decreasing at that point to completely solve either for that sort or this sort of functions.